We have seen insert, search, delete, and rehash. Now let's add up their costs and see the reason behind each one. Let's read the cost table row by row. Insert is big, O of 1 on average and big O of n in the worst case. When alpha is bounded, the chain or probe is short, but if every key collides, you get one long chain or a full scan. Search is the same. Big O of 1 on average, big O of n in the worst case, for the very same reason as insert. Delete is also big, O of 1 on average and big O of n at worst. It is one search, plus one unlink or one tombstone write. Rehash is big O of n per call because it touches every existing key once, but it is rare, so amortized over many inserts it is big O of 1. That is the chapter 3 argument again. So what does big O of 1 really mean here? With a good hash and alpha held low, finding one key among a million averages about one probe. You touch about one slot, not a million. That gap between average and worst is why we call it effectively big O of 1. This chart shows why the load factor matters. The bottom axis is alpha, the load factor. The side axis is the average number of probes. Follow the orange curve. It stays down near 1 or 2 probes while alpha is small, then it shoots upward as alpha gets close to 1. The green dashed line marks the rehash threshold at alpha equals 0.75. To the left of it, probes are cheap. The red dot sits at alpha equals 0.95, way up high, where probes average around 10. So why do we rehash around alpha equals 0.75? Because the average probe stays near 1 or 2 below that point, then climbs sharply as the table fills. Rehashing there keeps every operation close to big O of 1. Treat 0.75 as a common guideline, not a law. Different probing strategies shift where the curve bends. Now your turn. Looking at the curve, why is rehashing at alpha equals 0.95 already too late? Think about where the orange curve is by then. Let's check. By alpha equals 0.95, probes are already averaging around 10. The big O of 1 promise has quietly turned into something close to big O of n before the rehash even triggers.